Hey everybody, Mr. Bowman here, another video on 3.14 probability distributions. In this video, we're going through all the AMERIT questions from the 2019 exam. So let's get straight off into question number one. Just a reminder, all these questions are on the website link. I've got it in the comments or bio to this. And to note, in the previous question, you are asked to calculate the probability that something was less than 220. So we've got some zucchinis. They are picked when they are more than 190 millimeters long, but before they are 270 millimeters long. So that sounds like a minimum and a maximum to me. The most common length is something that was 220 millimeters long, and that explained kind of the probability that was mentioned here earlier. So for me, this is it's looking like a triangular distribution. So if you got your triangular distribution like this, you had the minimum value of 190, and that's when they were picked. We had the maximum value of 270, and then finally down the middle, it had a mode or a peak of 220 millimeters long. So for me, this looks like it's going to be a triangular distribution. And in this triangular distribution, the parameters, it had a minimum, a maximum, and a mode. So my A value, which is what the minimum would have been, is equal to 190 millimeters long. My B value, that's the maximum, and that there was going to be 270. And my C value, that's my mode, which was 220. 220. So that's where I was looking for. The question, reading to the question now, so now that we process it, it's a triangular distribution. I've got all my parameters, which is important for merit and excellence questions. Is the median length going to be more or less than 220? So we've already figured out from the previous question that this area here had a probability of 0.3375, which means we need to add on a little bit extra to get to the 50th percentile mark, which is what the median would have been, because the median is the middle number, right? So it would have been near the 50%. So because of that, we know the median has to be greater than the 220. So I just need to communicate that as part of my answer now. So the way I did that is, as the probability that x is greater than 200 is equal to 0.3375, the probability that x, oh gosh, I've written greater here, but that's meant to be less than, isn't it? The probability that x is greater than 220, that's going to be the rest of it, which is going to be, so must be 0.6625. So that was 1 minus our previous probability. The median would occur, and this is when I'm going to get into the 50th percentile stuff, around the 50th percentile. So 50th percentile, which would be greater than 220 millimeters. So that wraps up question number one. Bit of a weird question, but pretty easy once you get into it. Okay, so we are now on question number two, and this one was actually a drawing or a graph one, which doesn't happen too often, but we've got the normal distribution for the super sweet corn is shown on the graph below, so we've already got that one there. The new corn, Ambrosia sweet, is developed. Data has shown blah, 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 normal distribution model, and it says this new one has a mean of 149 with a standard deviation of 4 grams. So the first thing I always do for these drawing graphs is I try to figure out the width of the graph. So if you've got your 149 grams, and this is a rule of thumb type rule, if you plus or minus 3 lots of the standard deviation, that's going to get you to kind of almost all of the data. So we're going to go 149 plus or minus 12, and that's because each standard deviation is 4, so 4 times 3 is 12. And that means we're going to have 137 and then 161. So that means our graph is going to roughly lie in between 137 and 161. And so 161 is kind of here, 137 is over here. So you can see the graph is going to be a lot skinnier. So because it's not as wide as our blue graph, we know it's going to be taller. So it's going to look a lot taller, and almost all the graph should end up in those areas there. So let's try to do a better job of drawing this. So that there is going to be 137. Over here is going to be 161. And as we said, we know the mean is 149, which is going to be kind of over here, 149. So I know my peak of the graph, kind of on this line, it's going to be somewhere up there, and we know it's going to be above this because it's going to be a lot of a skinnier, narrow graph. So let's put it up over here. As long as it's over, you would have been fine here. And I'm not very good at drawing, particularly with my computer pen, but I'll give it a go. And I'm going to start quite low, kind of down here. Oh, sorry, need to be slightly higher. So I'm going to start quite low here, and I want to start going up when it hits 137, because that's roughly where the data is going to all be. And then it's going to go up all the way to my peak, and then I need to repeat the same down on the other end. So the graph is going to go into this, and then it's going to start going up at that particular point. So carrying on back down, it's going to go along down, and then it's going to go down like that. So you can see most of your data, it's within the 3 standard deviations that we calculated, and your peak is above the peak of the super sweet or the blue graph, and specifically the peak is at the exact mean of 149 grams. Okay, so I'm now on to question number 3, and we've got an organic weed killer. Attempted to reduce the number of weeds in a particular garden, and we've got 30 separate kind of 1 square meter shapes kind of recorded in the starter here. From a previous question, you would have calculated the mean to be 4.1667. Using your answer in part I, which is what we've got, and an appropriate distribution, so we're going to need to figure out what distribution to use. Comment on the chance that 10 weeds will be found in a plot that is 3 square meters. So I guess the first thing to note is the word per. So this is kind of per square meter. So it's there. That's normally the giveaway. That's going to be a percent distribution. So that's going to be the distribution I use. So I'm going to be using a percent distribution. And my lambda here is going to be triple what we've got here, because this was the mean per 1 square meter, but we've been asking for a 3 square meter area. So my lambda is going to be equal to 4.1667, and I'm going to multiply that there by 3, and my new mean is going to be 12.5 weeds per 3 meters squared. So now that I've got that, I can then actually go ahead and answer the question. So I'm looking for comment on the probability of the chance that there'll be 10 weeds. So that's exactly 10 weeds. So from the question I've got there, I know that I'm looking for x is equal to 10, and that there's going to be in the probability distribution mode. So that's the exact point mode. So the probability that x will be equal to 10, when I plug that into my graphics calculator, if you're not sure how to do that, let me know in the comments and I'll reply with a video explaining how to do that. But I got 0.0956, and I rounded that to 4 decimal points there. So I've done the math part of it. Following that, in your answer, you should justify your choice of a distribution and identify any parameters. So I've actually done the parameter part of it. I've talked about my calculator inputs, my lambda, my x. So parameters are done. So I just need to justify why was a percent distribution model appropriate here. So let's start typing up. So a percent distribution model was appropriate in this case. It is appropriate because, and I'm just going to bullet point my answer here. Feel free, you're always allowed to bullet point stuff. Percent distribution It was appropriate because, and let's start running through the criteria needed for a percent distribution. So the first thing is the percent distribution, data has to be discrete, so I should probably comment on that. There has to be an element of randomness to it. The events have to be independent from each other, has to be proportional, and cannot occur simultaneously. So these are the three things, or the five things, sorry, definitely not three there, that I'm going to want to talk about in my answer. So the number of weeds is a discrete number, which is consistent with a percent distribution. So that one's a nice easy one to figure out. So you need discrete data, and we've got discrete data and the number of weeds. Perfect. So the weeds have to be random, and I think we can all agree on this. If you think of your garden at home, there's no real rhyme or reason why weeds pop up where they do. They are random, so it makes sense. So the occurrence of weeds in a garden is fairly random and cannot be predicted. Also consistent with a percent distribution. Okay, so it's definitely random. Independent. Is the occurrence of one weed likely to be independent? Probably. Because of the randomness above, it makes me think they're independent. As weeds are random, they are likely to be independent. One weed isn't likely to attract other weeds from nearby. So it's not like they're calling their mates and asking them to come over or anything like that. Just edited around so got more typing room. So proportional, absolutely. So the fact, if you've got more garden space, you're expecting more weeds, and that's because the weeds will be proportional to the space available. So yeah, 100% it's going to be proportional. We would expect more weeds to occur as the garden size increases. This makes me think the number of weeds is proportional to the meter squared of the garden. And the last one, cannot occur simultaneously. Probably not. You can't really have two weeds being itself. You know what I mean? Like if you got two weeds, it's probably one weed's going to kill the other weed, and that one weed will just be bigger. So we can't really have two weeds occurring at the exact same time in the exact same space. So we cannot have two weeds occurring at the same time and same place. Also consistent with a percent distribution. I'll just write dist there. And I spelled percent wrong again, probably every time in the video here. So yeah, hopefully that makes sense. So it's looking pretty good for a percent distribution here model. It's ticking off most of the boxes. Nothing glaringly obvious coming out here. Okay, we are now on to question number 4, which is the last question, or the last merit question for this exam. So around 25% of the bush road potatoes are lighter than 186 grams. A normal distribution with a mean of 235 grams is used to model the weight of these potatoes. Using this normal distribution model, would you expect the percentage of bush road potatoes greater than 300 grams to be around 25%? We're not really sure, so we're going to have to go ahead and calculate that. So whilst it looks like we're given this probability, that doesn't actually count. We are trying to calculate this, and we're going to compare our number to that 25%. So we can't really use that information for anything. So the obvious standout here is we're not given a standard deviation, which means it's going to be pretty tough to use a normal distribution model or to find this probability without it. So the first thing that came to my head is, I'm probably going to have to use inverse normal distribution to find out the standard deviation of this particular graph, of this particular model. So using my model, so we have a mean of 235. That was given to us in the question. And we were told that 25% of them are lighter than 186 grams. So we know that as a fact. So let's call that there 186 grams. And I know this shaded area here, that there is going to be 0.25 or 25%. And as I stated before, the issue is we don't have the standard deviation. So we've got no idea where that's from. So to find this, we're going to have to use an inverse normal distribution model, and I'm going to have to standardize my curve to do that. So in a standard curve, the mean is 0 and the standard deviation is 1. And I'm trying to find out Z, how many standard deviations away from 0 this particular bit of data is. And the chunk I'm looking for is a 25% chunk. And that was given to us in our previous question. So for this part here, this is just an irregular inverse calculation. We can just use a graphics calculator to find out the missing X value, or not, in this case, the missing Z value. So if you plug that into your calculator, hopefully you got Z being equal to negative 0.6745. If you're not sure how to do that, do let me know in the comment section and I'll reply with a video that runs through step by step how to get that. But what we knew is we knew that we were going to have a left tail, so I would have had to put that in my calculator. I knew the area was 0.25, so again, that goes in the calculator, and the standard deviation of mean, they're the third and the fourth thing that would have needed to go into the calculator. Okay, so now that I've got that, I'm going to set up an equation with my Z formula. So Z is going to be equal to X minus the mean divided by the standard deviation. And the reason I want to do that is because standard deviation is one of the variables in this equation. So if I know the other three, I can use algebra and work backwards to find out what that standard deviation should have been. And I actually do have all three as well. So the first thing is I know my Z value, I've got it up here. So Z is going to be equal to negative 0.6745. That's going to be equal to X, which is up here. That was the original 186 given to us from our kind of 25% thing. We're going to minus the mean, which is 235, also given to us, and we're going to divide it by the standard deviation. So I'm just going to use a bit of algebra to figure this out. I'm going to simplify my numerator here. And at the same time, I'm actually going to move this over to the other side too. So it's currently division, so it's going to become multiplication. So it's negative 0.6745 times the standard deviation is going to be equal to negative 49. And both sides are negative, so let's drop the negative sign. So negative 6745 times the standard deviation is going to be equal to 49, which means the standard deviation is going to be 49 divided by 0.6745, which means my standard deviation is going to be equal to 72.65. Oh, I've written 66, but 65. And again, noting that was grams because of my units, and I rounded that to 2 decimal points. So I've got my standard deviation now. So I can actually go ahead and calculate that less than 300 gram statement before. So let's see if that's right. So I'm now going to draw yet another distribution curve. So my mean, 235. My standard deviation, just calculated that to be 72.65. And we're trying to find the probability that something's above 300 grams. So that's going to be over here. So let's call that 300. And we're trying to find this shaded area here. So using my calculator, it's going to be the NCD mode. My upper is going to be the big 9s. My lower would have been the 300. So these are all the calculator inputs you need. My mean was equal to 235 and my standard deviation 72.65. So when you plug all of that into your calculator, you're going to get the probability that X is being greater than 300. That's equal to 0.8155. Again, if you're not sure how to do this stuff on the calculator, let me know. I'll reply with a video. And now that we've got the number, we can actually compare it with a claim. It said it's going to be around 25%. And while it's close, I think, this is 6-7% off. That's quite a lot. That's almost a quarter off. So I'm not happy and I disagree with this claim. So now I'm just going to state that in a sentence. So we would not expect 25% of bush road potatoes to be greater than 300 grams, to be greater than 300 grams, we would expect, and I'm going to state my actual probability, we would expect 18.55%. So I disagree with the 25% claimed. Oh, spelled claimed. Horrific job at spelling claimed that, but there we go, claimed. So that wraps up this the video and all of these merit questions of the 2019 exam. So a lot of calculatory based stuff here. If you don't know how to do that, honestly, feel free to reach out and I'll try to help out via some comments, etc. Thanks so much for watching. Keep an eye out for the next lot of merit and excellence videos coming from all the distribution and all the concept stuff. Thanks heaps.